I think, did you have this on your notes yesterday? Was this the last example or not? I don't know where it left off.
Yeah.
I think this was the last example, but I wanted to go over it again because I want you to notice that these two are the exact same thing in both parentheses except for one's a plus and one's a minus. And when you have those, something really nice works out, right? So when I FOIL this, I get 3 times 3, which is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. And we do always treat I like a variable, except for when you have a power of 2 or more, because I squared actually equals negative 1. So these cancel out, right? And I squared is really negative 1. So you're really left with 9 plus 4, which gives you an answer of 13. These are called conjugates of each other, and because they're complex numbers, we say that they are complex conjugates. And so if you're trying to make an imaginary number go away, you can always multiply by its conjugate, and it will always equal a real number. Alright, because every time the middle part will cancel out, and the last part will equal that. So why is this important? Well, just like radicals, we don't like imaginary numbers in the bottom of our fraction, so we have to multiply by a conjugate to get rid of it. So that was the part that I didn't get to yesterday that will be today. Okay with that? You still writing this, or are you just doodling? Okay. So I wrote that just like radicals, you can't have an I in the denominator, so I don't know if you want to write that down or not. But this is the type of problem you're going to see today, where we have to move that imaginary part from the bottom to the top, just like we did with radicals a week or so ago. So when I see something like this that has addition and subtraction at the bottom, it's just like when we had to get rid of the radical. The only way I can move this I from the bottom of the fraction to the top is to multiply by its conjugate. And its conjugate is always exactly what's here, except for you change the sign in the middle. So since this is 3 plus 2i, I can multiply by 3 minus 2i. Why are we allowed to do this? Because if we do it to the bottom of the fraction, as long as we do it to the top of the fraction, we haven't really changed anything. We're just multiplying by 1. And just like radicals, it's okay to move the i's to the top. We just don't want them in the bottom. So I like to do the bottom of the fraction first because I know it always works out really nice. I don't even do the middle part of FOIL because I know it's going to cancel out. And then the top I have to go back and work out. But every time, if I take this times this, I'm going to get a real number, which is 9. I'm not even going to write my middle part down, but 3 times negative 2i would be negative 6i plus 6i. Are you okay with that if I skip writing that down? Because I know it's going to cancel out. And then 2i times negative 2i is negative 4i squared. And some people just go ahead and make that plus 4 because they know that the I squared is going to equal negative 1. On the top, since I just have one thing here, I have to distribute that, right? So 5i times 3 is 15i, and 5i times negative 2i is negative 10i squared. And then we just want to simplify that. I tend to kind of work above and below my problem so I don't have to rewrite it a whole bunch of times. Like I know that this is 4 times negative 1. That's just plus 4. So 9 plus 4 is 13. And on the top, that's negative 10 times negative 1. So that's 15i plus 10. Notice that your answer should never have anything bigger than I to the first power in it. because you can simplify everything else. If this bottom number is divisible by both of those, then we could simplify it, just like the quadratic. Like if that was a 5, we could have simplified it, but because it's a 13, we can't do anything. How do you feel about that? Overjoyed? I should have done that yesterday, but I didn't, because I was teaching with the baby on my hip, and it wasn't going through. So do this one, while I finish passing these out, and then we'll do the last thing for the day. You have to be a good PA.
Can I get a new sticker?
Nick needs some help.
I can't get my sticker.
He folded Sawyer's sticker on top of the paper, so have it on the side.
I think Nathan makes favorites. And I think he's only favorites himself.
Yeah, it's just
I think that's true.
I mean, I gotta stay up there. You gotta stick a first. I know my side.
On the last quiz that we had with the square root problem, it was the very last problem. A lot of people did not remember to multiply by a conjugate. So again, on this quiz, you'll see a question like this. It'll just say simplify, and you have to remember, oh, I have to multiply by the conjugate to move it up. And then you actually have to FOIL the top of this one out, because it's not like one thing over here. It's now two things times two things, so you actually have to FOIL the top. So you just want to watch your signs here. So I'm going to get 12y plus I minus 4y squared. And again, work be nice here, so when I'm grading these, I can see what you did. On the top, -4 times -1, that's really just going to become plus 4 there. So I think we get 7 minus 11i. And on the bottom, this is always going to become a plus because I squared is -1. So that's really 1 plus 16, which is 17. And I think that would be my answer.
What did we say as we pretend that if it's like a negative and you only have I squared, it's going to be opposite?
Yes,
right?
every time, because it's -1. Like, we could even go as far to say if you have a conjugate, a plus bi times a minus bi, every time that's going to equal a squared plus b squared. Because every time the first one's squared, the middle ones are going to cancel out, and then that's going to be minus, but the I squared makes it plus. So every time that does work. Okay? The other thing that we can do today is now we can solve quadratic equations that have imaginary solutions, which is something that you did a lot last year. Just in 1-2, they were just saying that wasn't a real solution, and now we can simplify some I stuff. So let's do a couple of those. Oh, and you don't really have to write this down. This is kind of what I just said. But now we can solve imaginary solutions by doing the square root method. Like, we can take the square root of a negative number, because we can pull the imaginary part out. We can complete the square with imaginary numbers, or we can do the quadratic formula. On your homework today, they don't tell you which way to do it. They just say solve it. So you're welcome to do some of both. I think I have 2 questions here. I'm going to do one completing the square and one quadratic formula just to remind you of that. But on your homework, you're welcome to do whatever you want. On the tests that we have, I will have like use quadratic formula, use completing the square, because I want to see that you can do both of those. Because on the unit test, it's like that. Would this be a good candidate for completing the square? There's nothing in front of x squared, and the middle number is even. So if you had to complete the square, this would be a good one to complete the square on. If you want to do the quadratic formula, I promise we should get the same answer. But just to remind you about completing the square, remember that we moved that last number over to the other side. And then what's the big thing that we do to complete the square? Half of b and square it, or half of the middle number and square it. So, oh my gosh, I don't even think this is in, half of -4 is -2, and -2 squared is 4. Agree with that? But if we add it over here, we also have to add it over there. And so if you Notice completing the square, that's pretty easy to do. I could probably do this quicker than I could do the quadratic formula. Because now I can just factor this, and it's always half of the middle number. So half of negative 4 was negative 2. And negative 8 plus 4 is negative 4. And then what's the next step? Square root both sides. Because when we square root a quantity squared, we just get back x minus 2. And how do I take the square root of negative 4? I can, because it's imaginary, right? Really, what you can break this up as the square root of 4 and the square root of negative 1. Right? That's kind of what you're thinking about when you have a negative number. What's the square root of 4? And what's the square root of negative 1? I. The square root of negative 1 is I. That's the definition of an imaginary number. So when you have a negative under your square root, you just have to pull the negative part out, and it's always an I. We are still taking the square root of both sides, so we do need to say plus or minus 2I. Even if this wasn't a perfect square, you'd still pull the I part out. Okay, if that was the square root of 5, negative 5, you would say that that would be the same as I radical 5. We don't keep the negative under the radical. And then my last step is going to be to add 2 over, and my answer is just going to look like that. Both of those are complex answers or imaginary answers, not real numbers. So let's do one more of these. All of the ones in your homework today might not have imaginary numbers in them. Like there might be some that have real numbers, but they're just all mixed up. So I didn't work them all out, so I don't know which ones are which. But I'm guessing there's a good amount of imaginary answers. This one, if I was forced to complete the square on this one, I could. But this one would not be my choice to complete the square on because we'd have to divide through by 3 first. So then we'd have a middle number of 4/3, and we'd have to take half of it, and we'd just be dealing with a lot of fractions. Not impossible to do, but not really my first choice. So this would be where I would choose the quadratic formula, and I would just plug my numbers in. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. You do have to know the quadratic formula. I will not give it to you on a test or quiz. 60, is that right? Yeah, so we get negative 44 all over 6. Everyone with me to that point? So again, remember you cannot simplify something inside a radical with something outside a radical. So when you see that negative 44, don't start dividing 2 into it. Break it up, simplify it. And could I write that as, what perfect square goes into 44? Yeah, so 4 times 11, but it is negative, so it's like you have that negative 1, or just know that there's an I in there. So we could write that as 2I with a square root 11 left over. So when it's a negative, you just pull the I out all over 6. You with me to that point? And then you got to watch this step here. 6, 4, and 2. Do they all share a common factor? So I can divide everything. You're never allowed to just divide this and this, or just this and this. But if they're all divisible by a number, I can go through and divide everything by 2, and my answer would be negative 2 plus or minus. You can put a 1 there if you want, but I'm just going to put I radical 11 all over 3. You do nothing with it. You're never going to change the radical because you can't simplify a radical with a number. And since it's all multiplication, it's okay that you can just simplify this part. Like just like if you had 2x over 6, you could simplify that and you just leave the x there. You kind of treat the radical the same way. Like it just stays there with it. The I just stays there with it. Okay? Discriminant, you don't have to rewrite this down, but maybe, remember we wrote discriminant out, I don't know, Friday, did we write stuff about discriminant? About On Friday, we said if it's less than 0, it's no real solution. I just want to point out that the correct thing to say is you might want to go back and just fill this in. Like, don't rewrite all that, but go back to your notes from 1, 2, to where we talked about the discriminant, and just be aware it's not mathematically correct to just say there's no real solution. If what's under your radical is negative, then you're going to have 2 complex answers, right? So maybe just kind of scratch that out on your notes and fill that in instead of rewriting it all. There are questions on your homework today that just say how many solutions and what are they just by looking at the discriminant. This is on the Unit 1 test, asking you to classify the answer based on the discriminant, so I want to make sure that you have that down. No need to rewrite the whole thing down, but we either have 2 real solutions, 1 real solution, or 2 complex solutions, depending on what's under the radical, okay? This is the last new stuff before our quiz. We're about maybe like halfway through chapter 1, maybe 1 or 2 more quizzes before we have our first big unit test. And I'm looking at that unit test. I think it's going to probably be a 2-day test for us, so I'll break it up like into day 1 and day 2 so you have enough time for it. Everybody okay with that? You got that written down? And this is in it is in your book, but I can go back and read it. So let me do the homework. This is 1, 3, day 2. And I kind of just picked some here. 24, 25, and 27, those are practicing with the conjugates. 47 through 50, those are just simplifying like the square root of -16. So those will be really quick to do. And then 57 through 66 multiples of 3, those are the quadratic formula. So that's 4 questions that you actually have to work out, either quadratic formula or completing the square. And then 74 and 77 are discriminant. So not too bad, especially 47 through 50 will be really quick. It is Pride 10 days, so you don't have that much time. Yeah. Like 42, so like 4 minutes. Tomorrow we'll review, and I'm not going to do a whole bunch